I will discuss about the sheet metal forming and plastic processing techniques under unit 4, and learning end of this lecture, that is the learning outcomes. End of this lecture, student will able to learn about the explain the basis of sheet metal forming and plastic processing techniques. What are the contents under unit 4? First one, introduction. Role of sheet components, sharing mechanism, various press working operation, press for sheet metal working and press tools, die and punch, different type of die, blanking and piercing, forces and load estimation in forming, deep drawing, stretch forming, bending, coining, spinning, spring back and its remedies. High energy forming process, principle of explosive forming, electromagnetic forming, electrohydraulic forming and rubber pad forming, advantages and limitations. Plastic processing, types of plastic, properties, application and their processing methods, blow molding and injection molding. Now introduction. What are the learning outcomes of introduction part? At the end of this lecture, student will able to learn about the role of sheet components and sheet metal forming. Now we are coming to discussion of sheet metal forming. What are the type of cutting operations? First one, cut off. Cut off means each cut off is a new part. Each cut is a new part. That is the cut off. Parting. Parting means two cutting edges. Parting means two cutting edges, that is less efficient and scrap will be generated. Then slotting, punching a hole, that is called slotting. Perforating means preparing a pattern, that is the perforating. Notching, notching means edge portion of the metal sheet will be removed, that is notching. Trimming, shaving and fine blanking, that operations to clean and smooth out edges. By this operation, trimming, shaving and fine blanking, that process used to clean up and smooth the cutting edges. Introduction. What happens in sheet metal forming? Sheet metal, simply metal formed into thin and flat pieces. Sheet metal is simply metal formed into thin and flat pieces. Sheet metal generally has been done metal process into sheets. These sheets are used in various places. That sheets may be bent, may be cut or may be taken any type of shape using sheet metal forming operations. Sheet metal generally produced in sheet by reducing the thickness of the workpiece. Sometimes we are taken thicker material, thicker workpiece we have taken, and using sheet metal forming process we reduce the thickness of that particular work pieces by applying the compressive force using through set of rolls, and using compressive force or compression force we reduce the thickness of the sheet metal. That is the billet material, that is the thin means that is the thicker material before sheet metal forming. Okay, that are the smooth rollers. That are rotating in this direction. It is rotating in this direction. Both are smooth rollers. Okay, and we passes these thick sheets through that particular roller. Okay, after that what happens? The thickness of this particular thickness will be decreases of that particular thick sheets. That are some required rollers that also helps to reduce the thickness of that particular thick sheets, and that is the sheets, that is the thin sheets, that is the thicker sheets, and sometimes we have used the water cooling. Why we use the water cooling? Reduce the temperature of that particular thin sheets. Means after forming the thin sheet, the temperature will be increases. For reducing the temperature of that thin sheets, we use the water cooling operation. Sheet metal forming. So how to differentiate sheet and plate? What is the difference between sheet and plate? If thickness is less than 6 millimeter, means 1/4 inches, then it is regarded as a sheet. If thickness is less than 6 millimeter or 1/4 inches, that is called sheet. If thickness is greater than 6 millimeter, means 1/4 inches, then it is regarded as a plate. What are the application of the sheet metals? First of all, aircraft bodies, automobile bodies, utensils used for domestic purposes, beverage cars. So different applications we have used the sheet metal. Different applications of the sheet metal. Aircraft operation, automobile operations, utensils operations, and sometimes aircraft utensil, sometimes beverage cans also we have produced using sheet metals. So different uses are there in case of sheet metal forming operation. What are the sheet metal operations? Shearing, blanking, bending, stretch forming, deep drawing and redrawing, etc. Different sheet metal operations are there. Sheet metal characteristics. What are the sheet metal characteristics? Sheet metal generally is characterized by the higher ratio of surface area to thickness. Okay, sheet metal characterized by high ratio of surface area to thickness. Second, forming generally carried out by tensile stresses. Forming operation generally carried out by tensile stresses. Okay. During decreasing of thickness of that particular sheet metal, we avoid it as far as possible. They can lead to necking. Means if we are taking more and more, thickness will be reduced of that particular sheet. So at that time maybe it lead to necking and failure. So always we are taken care about that things. Means we are converted into thin sheet as per our requirement, not more than that. If we are taking more thinness of that particular sheet metal, what happens? Necking and failure will be take place in that particular sheet. What are the major factors that will influence the sheet metal characteristics? Elongation, means if we are providing the more tensile forces, it will more elongate it. Okay. Anisotropy, grain size, residual stresses, spring back and wrinkling, that are the important factors that will affect the total sheet metal characteristics. Elongation. Here if we are producing for elongation purpose, ductility of the material is necessary. Means ductility means it is the property of a material, it will drawn into wires. So when we test it, tensile strength elongates the certain amount of before fracture takes place. If we are providing the tensile force, in that time what happens? Now the material will be elongated. Okay, and after certain time it will taken failure. So we are taken elongation up to our limit, means as per our requirement, not before that. The two pieces are placed together and the amount of extension is measured against mark made before starting the test and expressed as a percentage of the original gauge length. So always we are taken care about the elongation of that particular material. Materials like low carbon steel exhibit a behavior called a yield point elongations. Means that low carbon steel will be elongated below the yield point. Okay, and exhibiting upper yield point and lower yield point, that also shown in case of low carbon steel. Higher elongation leads to larger band of stain marks. Means higher elongation forms two larger band or stain marks will be created in that particular thin sheet metal. To avoid this reduced yield point elongation by reducing the thickness. So step by step we reduce the thickness by cold rolling. So generally we have reduced the thickness of the seed by 0.5% to 1.5% by the cold rolling. That is called temper rolling. Now ladder bands or strain marks, that is the ladder bands or strain marks will be formed due to higher elongation in that particular thin sheets. Anisotrophy. What is anisotrophy? That is generally two types of anisotrophy. One is crystallographic anisotrophy, means crystallographic anisotrophy means here the grain orientation has been shown in that particular anisotropy. And mechanical fibering means here alignment of the impurities, voids, inclusions that are present in case of mechanical fibering. Okay, the anisotropy present in plane of the sheet is called planar anisotrophy, and the anisotropy present in thickness direction is called normal anisotropy. That is, are two types of anisotropy. One is crystallography anisotropy, another is the mechanical fibering. Anisotropy, planar anisotropy are given by the R equals to R0 plus 2R45 plus R90 by 4. Here subscript 0, 45, 90 refer to the angular orientation of that particular specimen with respect to rolling direction of that sheet. Grain size, coarser grain size, the surface finish which affects the coarser grain, rougher the surface finish, means coarse grain size, it leads to rougher surface finish to that particular sheet. Generally ASTM, American Society for Testing Materials, grain size number 7 is preferred for general sheet metal forming. Generally ASTM grain size of number 7 is preferred for the general sheet metal forming operation. So that sheet is the very standard sheet. It is applicable in case of sheet metal forming operations. Residual stresses means it will develop during metal forming operation due to non-uniform deformation. Due to non-uniform deformation, residual stress can be developed in the sheet metal. When disturbed, such as by removing the portion of it, the part may be distorted. If we are, when disturbed such as by removing portion of it, if we want to remove that things, so sometimes the sheet may be distorted. Tensile residual stress lead to sometimes very higher tensile stresses, sometimes lead to stress corrosion cracking of that part. Sometimes higher tensile residual stresses sometimes lead to higher corrosion cracking. Wrinkling. So what happens in that process? Now compressive stresses are formed in that particular plane that results due to higher compressive stress are formed in that particular plane. So due to that thing sometimes wrinkling or buckling will be happened. The tendency of wrinkling increases with the unsupported length of that sheet metal, means when we applying the compressive force on that particular sheet metal, here if we do not provide any support on that particular thing, sometimes it will be bent, and due to that thing that buckling or wrinkling takes place in that particular sheet metal. Here decreasing the thickness and non-uniformity has been takes place in that particular sheet metal also. Lubricant strap can also be contribute to wrinkling. Sometimes we provided some lubricants in that sheet metal forming operations. Okay, so at that time if we are provided the lubricants in that sheet metal forming operation, so sometimes it also helps to wrinkling defects. shearing operation. What is that particular shearing operation? Means that is the process of cutting sheet metal to size out larger stock such as roll stock. Means shearing operation has been used for cutting sheet metal, okay, to a size out of larger stock. Means we have cut the particular sheet as per our requirement from the large stock such as roll stock, okay. That are the shearing operation. Means that are the cutting portion of the shearing operation that will cut. Means it will maintain some distance, very less distance we have provided between the two cutting portions, and that is the sheet. Means that is the blades, that is called blades, cutting blades, okay. And then we press here and it will cut some portion, then again we will press some cut portion, and due to after that it will fully cut and it will divided that particular sheet. Shearing machine, that is the one example of the shearing machine. Using that machine we cut some thin sheet metal. Shearing, in case of generally shearing operation, that material thickness ranges from 0.125 millimeter to 6.335 millimeter, means 0.005 to 0.0250 inches. Up to that thickness we have used for shearing operation, and dimensional tolerance ranging from plus minus 0.125 millimeter to plus minus 1.5 millimeter. Up to that tolerance ranges varies in that shearing operation. And also shearing process produces shear edges bar. Sometimes when we do the shearing operation, sometimes shearing edge bar will be formed, which can be minimized less than 10% of the material thickness. If we are taken the less than 10% of the material thickness, so using that thing we reduce the shear edge bar formation. The major variables affect the shearing are, what are the major variables which affect the shearing operation? What are the major variables? First one, punch force, speed of the punch, lubrication, the hardness of the punch and die materials, and the corner radii of the punch and the clearance between the die and punch. That things affect the shearing operations. Variables affecting the shearing, variables affecting the shearing. First one, shear force. Shear force is basically product of shear strength of the sheet metal and the cross sectional area being sheared. So here we can write F max means shear force equals to 0.7 into UTS, means ultimate tensile strength, into thickness into total length of shear, that is the total shear force, total shear edge. For round hole of a diameter d equals to, we can write here, for round hole of the diameter here total length, if diameter d, total length will be equals to pi into d. Maximum force can be obtained only when maximum speed is derived or vice versa. Okay, so using that formula we calculate the shear force. Engineering analysis, cutting force. What will be the cutting force? F equals to S, means shear strength, into T, thickness of that particular sheet, into length of the cutting edge, that is the cutting force. Again F equals to 0.7 T, S means ultimate tensile strength, and T, thickness of that particular material, and into L, that is the length of the cutting edge. So maximum F is used to determine press for operation. Okay, that are the some engineering analysis of the cutting force. Using that formula we calculate the cutting force. Hardness, bar radius on cutting surfaces. So sometimes optimum hardness, more than required hardness, would make it brittle. If we are taking more hardness in that particular material, so the material will be brittle, and lesser would withstand the higher force. Means lesser hardness, lesser harder material will not withstand the higher force. Bar are small projections that are formed on other surfaces of a formed component. Means if sometimes during the shearing operation sometimes bar will be formed, okay, that surface are not acceptable in our cutting operation, but we are taking some affecting parameters, we control some affecting parameters, are using that affecting parameters we control the bar formation. Small radius should be given to cutting surfaces, to impact strength it should be optimum, okay, means small radius should be given to the cutting portion to impart strain and it should be optimum. Clearance between punch die and clearance between two cutting blades. Here we are seeing that is the punch P, okay, that is the punch and that are the two die. That are two die, that is the die and that is the punch. So some clearance will be provided between punch and die, that is the clearance. Here clearance, that is the, if diameter of the punch D1 and the diameter of that between two die means distance between two die, that is the D, okay. So total clearance, so here we can write the clearance between punch and die, that is the C by 2 and that is the C by 2. In this way we divide the clearance between punch and die. Means here we can see that here C, here C, just we divided by 2 for getting the clearance both the sides. Engineering analysis. Now clearance, distance between punch and die. Another 4 to 8% of the sheet thickness, that is the acceptable, and small clearance due to providing the small clearance sometimes bar formation also reduces. Double varnishing, large cutting force also we have applied between due to less clearance. Large clearance, due to large clearance what happens, the sheet becomes pinched, sometimes sheet becomes pinched and excessive bar will be formed. So smaller clearance will be suitable in case of during cutting time. Clearance, total clearance C equals to D minus D1. D means distance between two die and minus D1 means the punch die. Therefore clearance per side C equals to C by 2 per side, clearance per side. Also clearance per side C by 2 is given by C by 2 equals to 0.01 into S means material thickness and square root of TB means shear stress, okay. Using that formula also we have calculated the clearance. Generally 5 to 10% of the material thickness. Using that percentage generally we maintain the clearance between punch and die. Clearance effect, what will be the effect of the clearance? Greater clearance, rough edges formation of the bar material will be pulled rather being cut. Larger clearance leads to rough edges and formation of the bar. Smaller clearance that have good cut edges, forces required is more, also tool withdrawal is difficult. So sometimes due to smaller clearance the cutting edges will be good and also force also we have got more. Sometimes what have problem is tool withdrawal, sometimes it will create the difficult. So high compressive stress we have got in case of smaller clearance we have provide between punch and die, okay. That is the entry side, means here we provide the force and that is the die, and due to application of the high compressive force it will take form the particular shape or it will cut of that particular material, that is the punch force acting across this side. And sometimes after punching operation we want to remove the withdrawal the particular punch, so sometimes that time due to smaller clearance maybe some effect will be produced in that particular cutting edge during the across the cutting edge. High stripping force is required for removal of that particular punch. Generally, what are the tool and die materials? Tool and die materials are generally used die steel, HSS, high speed steel, that is the most common materials in case of tool and die materials. For higher production, generally we have used the carbide material. For higher production, we have used the carbide materials. Scraps, amount of scrap can be high as up to 30% of the original sheet. Generally, maximum scrap will be generated maximum up to 30% of the original sheet. So how we can reduce that thing? That will be reduced by the proper nesting. By the proper nesting, we have reduced the scrap generation. And end of this lecture, the student will able to learn about the role of sheet components and sheet metal forming. Sheet metal forming operations. Means a piece of metal whose thickness is between 0.5 mm to 6 mm, it's called sheet metal. We are coming to sheet metal operation. That is the die, channel bending we are taken, particular thin sheets, that is the die. That is the punch, and that is the particular sheet, and on that particular sheet we take the particular shape will be formed in that particular sheet. That type of shape will be formed of that particular thin sheet. Means that is the forming, means bending operation, that is one type of sheet metal forming operation. Channel bending, it is called channel bending. Also you will see other bending operations also. That is one type of sheet metal forming operation. That type of sheet metal will be also across the V shape, that type of shape also forming in that particular sheet metal, that type of shape also formed as per die shape. That type of shape also formed in that particular sheet metal. Now we are coming to shearing operation. Shearing, by the upper blade the sheet metal will be cut. Means also we have taken as a scissor for shearing operation also. Using scissor also we have cut the some metals. Means some gaps are provided between two blades. Sometimes we provided greater clearance, and also we will provide the smaller clearance. Greater clearance creates the bar type on that cutting edge. If we are taken smaller clearance, so the cutting edge will be better. In that way the thin sheet will be cut. That is the shearing operation. 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 By the shearing we cut the some materials. Punching and blanking operations. Blanking, piercing and punching. Blanking operation, that is the sheet metal, and that is the punch, and that is the die. Using the punch we cut some metal, that is the blank final part, that is the scrap part, that is the blanking operation. Now we are coming to piercing operation. Here that is the punch, and that is the sheet metal, that is the die, and using the punch by applying force, one particular the material will be formed, that is the scrap, and that is the final part, final product, and that is the pierce hole, that is the piercing operation. Now we are coming to punching. As like piercing operation, as like punching operation. Modify existing blank sheet. After large sheet, after punching, and that is the finished product, and that is the scrap. Means existing things we have got again the final product. That is the blanking scrap, that is the blank part, means punch part, and that is the final part. Means here we have seen that is the blanking, that is the scrap part, that is the blank part. Here punched hole is the scrap part and that is the final product, and that is the RAM, that is the piercing operation. And in case of punching operation, that is the finished or existing product. Here we with the punching operation, that is the final part and that is the scrap part. But here punching, piercing as like same operations.